My name is Manikiran and I am from CSC for Gayatri Vidya Parishad College of Engineering. And let us discuss about our main topics and what are the topics to be covered. First, why this topic is important. Nowadays, the technology and the computation works depends upon the various hardware software executions, and for that we need major concepts of programming, debugging, and code optimization. Today, we are going to discuss about the topics user mode and kernel mode, system calls, compiler and interpreter, Java virtual machine. First, let's discuss about the user mode and kernel mode. What is user mode and what is kernel mode? User mode allows the limited access to the system resources and applications that are run in this mode. Only the main applications are only run in this mode, and if any of this is fails, the system or the process will crashes. The main examples that are programs applications that are run on the user mode is browsers and text editors. Kernel mode. Kernel mode gives the full access to the hardware and memory. In kernel mode, majorly the operating system runs on this mode. If the operating system or the process that fails, then it crashes the entire system. Let us go deep towards the user mode. User mode is restricted to words in which the application program runs. That means when a particular application runs in a system, the user mode will be limited only to that particular program. It cannot directly access the hardware or system resources like memory, I/O devices, and many more. For that, it needs some requests to the operating system through system calls. We can learn deeply for the system calls in our next slides. And we already discussed that if any application crashes, it does not affect the complete system. It only terminates that particular application. The major examples are some of examples for this user mode is web browsers, text editors, media players, and other applications. Let us discuss about the kernel mode. Kernel mode is a privileged mode where the operating system operates. The kernel has full access to the system hardware and can execute the privileged instructions. Unlike the user mode, the kernel mode has access to the system hardware like memory, input, output, and many more. So it does not need any particular system calls to execute the operations. Here we also understand that in kernel mode, the operating system functions run directly. If any of a particular operating system or a process is failed, then the entire system will crashes. The main reason why we need two modes. The major two are security and efficiency. Coming to security, to prevent applications that directly accessing the critical resources. Like there are some applications which are third-party applications which we run on the user mode. Those applications may cause the threat to our system. So we do not accept allow them to use the system resources directly. So we use user mode and kernel mode. And efficiency by switching optimizes the execution based on the requirements. As we let us consider the working on a web browser. For that, if we allow the web browser all the resources, it may take the system to lag. So we need to switch the modes between the user mode and kernel mode. Let us take a simple case view of the user mode and kernel mode. Here the picture represents the switching between the user mode and kernel mode. Here execution process starts, and for that it takes a system call. The system call runs in the kernel mode, and then the kernel mode returns the system call output. Now let us discuss deeply towards the system calls. Starting with the definition, what is the system call? Interface between the user application and the operating system kernel. As we already discussed that the user applications or user mode cannot access directly the operating system and its features. So it need a particular set of applications or an interface in between them to act as a mediator. So we need system calls. Why it is needed? Applications cannot directly interact with hardware due to the security constraints. Example, opening a file, creating a process, allocation memory. There are several system calls which we use in our daily life, like reading, opening files, and many more. Majorly, there are 5 types of system calls: process control, file management, device management, information maintenance, and communication. These all system calls which are used in our daily day-to-day life, but we do not know them perfectly as they run inside the system. First of all, the process control. The major three process control system calls are fork, exec, and exit. Fork is used to copy the particular thread or process and execute that particular process, and exit to terminate the particular process. File management has the majorly four system calls. They are open, read, write, and close. Open system call is used to open a particular file, read to read the data inside that file, and write system call uses to manipulate or changes the data in that particular file. After the completion of the reading or writing operations, we use the system call close to terminate that particular operations and close that file. And for device management, we use the same system calls like IOCLT, IOCDL, read and write. For information maintenance, we get the GAT, get PID, and alarm. Get PID is the system call which is used to retrieve the data from the system on which on which process it was executing. PID represents the process ID. Through this method or a system call, we retrieve the data which process is currently executing. And our last system call type is communication pipes, SM, SHM, get, and socket. These are the several system calls which we use in our daily life. This is the below picture represents the execution of a system call. Here we can see that the beginning of execution to the ending of execution whole process. First of all, the in user interface or user mode, the application requires a system call. That means when we need a particular operation to be done, we use the system call. And then that application will go to the function library, which is mapped through a map. And later on that, the user mode switches to the kernel mode. And through this function library, we can go to the operating system call handler. The system call handler handles that particular system call which was given by the user application. And this handler moves to a control towards the particular function which the system call which is required, and then the function will go towards the functional library which was done in the user mode, and finally the application gets the system call results. This can be done in for every system call process, and this is the basic example of the system call. For example, if we wanna read a particular file, for that we need a system call named as the open, which was consider a variable name that is empty. And to open the data, we use the function system call open. Inside that we pass two parameters. First one is the name of the file, and second one is the permission that we need. First one is the name of the file, that was the file.txt, and read only. That means we can only read the data, we cannot overwrite the data inside it. If we do not find any file in our library, it will return a error message. Our next topic is compiler versus interpreter. This is the basic differences between the compiler and interpreter. Compiler displays all errors after the compilation all at the same time. Faster execution. Intermediate object requires memory. And coming to the interpreter, the displays all the errors each line by line. Slower execution, no intermediate object, no memory requirement. The major examples are the C, C++, PHP, Ruby, and Python. Let us discuss deeply in our next slides. What is compiler? Compiler is a program that converts the high-level code into machine understandable code before execution. This is the main point before execution. Here, a compiler and interpreter do the same thing, which converts the high-level language code to the low-level or a machine understanding code. Here, where there are several types of compilers and interpreters. The famous examples are GCC compiler for C and C++, and Java C compiler for Java. Characteristics of compilers. This may vary between the interpreter and compiler. Characteristics. Converts entire code at once. In compiler, when we give a particular fragment of code, it completely converts the code into binary data or a machine understandable code. For this, the execution speed of a compiler is very fast. But when it comes to compilation, as the line to line was not implemented, it may take lower compilation. And after the full compilation only, the errors are displayed, which may lead to the time wastage. Coming to the interpreter. Interpreter is a program that executes the high-level code line by line. This interpreter also do the same thing, which converts the high-level language code to the machine understandable language. But when it converts the code in between these two languages, it executes line by line. The famous examples are Python interpreter and the JavaScript engine. Characteristics. Executes the code step by step. That means when we give a code fragment of 10 lines, it executes each line by line. And after that, it uses the debugging. It debugs and returns the error for each line. As we can see, the slower execution but useful for debugging. Compiler uses the execution speed a little faster, but compilation is slow. In interpreter, there is no term of compilation, but its execution is very slow, as line by line is verified thoroughly, so that it is useful for debugging the code to understand where the error is caused, and it stops at first error encountered. Suppose there is a code of 10 lines, and at the fifth line we captured error, so that the execution will stop at the fifth line. It cannot consider the sixth line, seventh line, eighth line, ninth line, because it stops at that particular point and asks the user to correct it. This interpreter is used for the debugging process. These are the key differences between the interpreter and compiler. First of all, compiler. Compiler takes entire program as an input. We already discussed about this thing, that the compiler takes entire program as an input and it converts all the thing towards the binary, whereas interpreter takes the single instruction as an input. It considers line by line execution. Intermediate object code is generated. In when it comes to compiler, let us consider about the Java compiler. The when it compiles the .java file, it returns the .obj or .object file, the object file that can run on any type of machine. Whereas interpreter, there is no object code generation; it directly executes the data. Conditional control statements are executes faster, as we can already understand that the execution fast is very faster, whereas interpreter has slower execution. Compiler needs more memory requirement, whereas the interpreter needs less requirement. Programs need to be compiled every time. So the compiler compiles the program line by line, compiles the program completely at once, so that if we alter any particular change on a particular line, it may lead to the compilation of whole program once again. Whereas an interpreter, after the completion of the completely converting the particular code into a machine learning language, if we alter the code, we can particularly run that particular line so that it may easier execution. Examples are C compiler, interpreter for used for the basic and Python interpreter. Our next topic is JVM. JVM is also called as the Java Virtual Machine. Java Virtual Machine is a virtual machine that runs the Java bytecode. And in this Java is write only run everywhere capability. Java has a particular feature that WORA, which is write once and run everywhere, run anywhere. As we already discussed that when a Java file is compiled, the compiled code is returns the object file, in which the object file can run in any operating system or any system. And the next question arises that the why this JVM? This JVM provides the platform independence, as the right ones run anywhere capability promotes this one only, and handles memory management, the garbage collection. Garbage collection is the feature in the Java where the unused variables or objects that are automatically deleted from the system. Ensures the security through bytecode verification. And JVM ensures that the security, which may have helps the code to be anti-theft. Coming to the JVM architecture, JVM architecture has mainly four parts: class loader, memory areas, execution engine, and garbage collector. These are the major features of the JVM architecture. First of all, coming to the class loader, loads the class files into memory. Memory areas. Memory areas are of four: stack, heap, memory area, and PC register. These registers are in the system. Stacks and heap are used to hold the static variables and the dynamic variables. Execution engine converts the bytecode into machine under instructions. So after the compilation of the code, this bytecode is generated, and this bytecode is converted into machine understandable language. Garbage collector automatically deallocates unusable objects. This is the analogy of the JVM architecture. First of all, .class file is sent towards the class loader, a subsystem, and this class loader you can use the data and send it to the runtime data areas, and later on that this runtime data area send the data into the Java method interface, which also has the Java libraries and many more. Later on that the file data is sent to the interpreter or JIT compiler. These both are at a single page, which is also known as the execution engine. After all that, after the complete execution of the code, it retrieves the data into the operating system. Java execution process. Java execution process was done in the three stages: compilation, class loading, and execution. First of all, the .java file is sent into the Java compiler, which was Java C, and later on that this Java compiler returns a .class file, and this .class file is sent to the class loader. Class loader converts the code into bytecode. Bytecode is verified, and bytecode is verified. The verified bytecode is sent to the Java runtime system, and Java runtime system sends the data into the native OS. This is the execution process of the Java virtual machine.